Okay, so hopefully everyone remembers the Pythagorean theorem. And you can write your answers however you want to write your answers, but I want to make sure you are clear. There is one hypotenuse and there are two legs. The order that you add the two legs in does not matter. But the hypotenuse is always the longest side of the triangle opposite the 90-degree angle. Then the next thing we are heading into is we have ratios. Sine, cosine, and tangent are our starters, and you've probably worked with them before. But there's some things I want you to write in here because I found that people were confused when I started using Greek letters. So know that it is really common to use Greek letters as a variable for an angle. You're probably used to using maybe capital letters for the angle because that tends to be the way it's done in geometry. But once you're past geometry and using the trig, usually we put a Greek letter and we draw it inside. So like how this says capital A, if I put a symbol right here, then I'm saying the measurement of this angle, right, is whatever theta represents. And it's very important for you to understand. You remember the whole opposite, adjacent, hypotenuse thing. The side that is opposite and the side that is adjacent depends on which angle you are working with. So when I come back over here to this triangle, right now with how I put theta in the location of capital A, that means that this lowercase a is for that angle, the opposite side, and B is the adjacent side. And remember that the adjacent side makes one of the sides of the angle. But if I decide to use this angle here, and I'll put alpha, when I'm using that one, that changes who is opposite and who is adjacent for the legs. Now, opposite that angle is side B, adjacent is side A, where A and the hypotenuse make angle alpha. When I was working with theta, length, side B and the hypotenuse made that angle. Now, sine, cosine, tangent. SOH-CAH TOA. Did everyone learn the phrase SOH-CAH TOA to help with the memorization? Good. Because you have to make sure these three are memorized. Know that tomorrow, good. Know that tomorrow we are going to be adding 3 additional trig functions to our plate. And it's likely you haven't seen those trig functions before. What? Okay, I don't know. Anyway, make sure that you have these 3 well in your head. Very, very memorized. When someone says sine, you just immediately turn to opposite over hypotenuse. So, okay, I'm trying to follow the chat. And did some of you not learn SOH-CAH TOA? Okay, maybe I should just, in case, point out The SO says sine is opposite over hypotenuse. CAH says cosine is adjacent over hypotenuse. TOA says tangent is opposite over adjacent. And know that you're not allowed to write the three letters without an angle variable or an angle number written right after it. These functions don't make sense if you write the three letters only and write nothing else. If you don't want to write the angle, you have to write out the word. So these are the full words, but when we talk about the function, we write the angle afterward. Okay, make sure again that you have those memorized. Oh, my examples didn't make it on the right page. Okay, I'll have to fix that later. So, examples. Here we go. You know this leg is 6. This hypotenuse is 18. Can you find the missing side? Dun, dun, dun. And does everyone realize that that means use Pythagorean theorem? Excellent. And once you find the length of this side, I want you to write the actual ratios. Now, I can actually write cosine right now. What? We have a C and an A. C squared. Okay. Yeah. So if you want to find this length, you can call it any letter you want. It's up to you. A lot of people will just put an X on it. So you're going to have x squared plus 6 squared equals 18 squared. And then you're going to solve that. And hold on just a second. I want to say that without finding x, right now this is ready for cosine theta because this is the adjacent side. This is the hypotenuse. So every time you get a right triangle, you need to first figure out which side is the hypotenuse. Then if there's a specific angle that is being worked with, you want to figure out of the two legs that make the right angle, which one is adjacent and which one is opposite. So when I go to write cosine, which is the adjacent side divided by the hypotenuse, I would start by writing 6 over 18 and then just reduce it. And 6 times 3 is 18, so that reduces to 1/3. And now I'm just going to put the answers up. Doot, doot, doot. So for the 16.97, someone wrote that a little bit ago. Yes, that is correct. Yeah.
Is a tangent problem for number 1 wrong? Because on the answer key, you said for the adjacent part it's 18, which shouldn't it be 6?
Oh, silly me. I need to correct that, and you are right. You are absolutely right. I messed that up. The adjacent side is 6. And why do I have an 18? Because I wrote a 6 over there. I think I was doing a copy paste and just failed to change that one item while I was doing copy paste. In red, I have the 6 written there, so I need to go back and change that. But thank you, because I need to fix that. Okay, do you feel comfortable with problem number 1? All right. Problem number 2. Just do it one more time. It's probably been a while since you've used SOH-CAH TOA, so it's bringing it all back. And you can use a calculator. So the hypotenuse, if I call it C, then I end up with this equation, and you can use your calculator to find the C. And with theta being this particular angle, then between the two legs, the leg that helps to make it is adjacent, and the leg that it does not touch is its opposite. And I'm going to go ahead and put the answers up. And so you should be getting these values, unless I screwed up again, of course.
So is the 14 side or the opposite side?
The 14 is adjacent. And it's adjacent because this is the angle theta. So when you look at the two legs that make the right angle, the adjacent is the one leg who is one of the sides of theta. The hypotenuse is the other side. And then the opposite doesn't touch theta. So it's important, it's really important that you're clear that, why did I just write I was meaning to write adjacent. Okay. Make sure you're clear that the side that is opposite and the side that is adjacent depends on which angle you're working with, because there are two acute angles in a right triangle. This one got named, but if I had named this one instead, this one would see 14 as its opposite, and the side that's 9 would be adjacent with respect to that angle. The hypotenuse is the only one that just gets to be stable, but adjacent and opposite are based on which of the two acute angles you're using. All right, do you feel like you've had enough time to do number 2? And write down your 3 trig ratios? And I've got to say, the most important thing for you to do today is make sure that you have SOH-CAH TOA memorized. You know that sine is opposite over hypotenuse. You know that cosine is adjacent over hypotenuse. And you know that tangent is opposite over adjacent. You want to come in tomorrow with that very, very solid. Because like I said, we're going to get 3 new trig functions coming into play tomorrow. All right. Then let's go on to the next bit. Special right triangle formulas. Do you guys remember these? Now, I want to talk through where these formulas come from. Maybe some of you already know, but I'm going to go through them just to make sure. So, I'm going to start off right here with a 45, 45, 90. Does everyone remember that if you have a pair of congruent angles, that means the sides that are opposite those two angles are themselves congruent. So what I'm actually wanting to show is if those two are congruent, then these two are congruent. Yeah, there are a lot of things we forget, but hopefully this brings it back to you. So that means that if I put an x down as a variable for one of the legs, the other leg is also x. And then I want to know a formula for finding the hypotenuse. So if these are both x, then hypotenuse squared is equal to x. Why did it do that? I don't know. That you're not listening to me, are you? I'm yelling at my computer, and now I realize I don't have my glove on. So hypotenuse is equal to, hypotenuse squared is x squared plus x squared. X squared plus x squared is 2x squared. Then if I take the square root, the hypotenuse that is not being squared is equal to the square root of 2x squared. And the properties of roots allow us to distribute the root over multiplication. So we end up getting the square root of 2 times x. So if you know the length of a side of a 45, 45, 90, the hypotenuse is that side multiplied by root 2. All right, so that is your 45, 45, 90 that you need to know. Let's come back up here where just go back a little bit, and now on the first triangles, let's put x and x times the square root of 2. For the 30, 60, 90, I have the unknown side sitting across from 30 because that makes our formulas easier. It allows us to have formulas that aren't fractional. So here we go. A 30, 60, 90 is actually half of an equilateral triangle. So if I say that the side across from 30 degrees is length x, then the length of any side of this equilateral triangle has to be double that. Would you agree? The altitude is cutting that triangle right in half. So what that means is if this is an equilateral triangle, the hypotenuse is twice as long as the side across from 30. Then, in order to determine the altitude of this triangle, which will tell me the side across from 60, I know that leg squared plus leg squared equals hypotenuse squared. So what I have here is the altitude that I need to find, that squared plus this side, x squared, is equal to this length, 2x quantity squared. And we're going to find the formula for the side opposite 60 degrees. So when I isolate the altitude squared, I need to take my 2x squared and subtract from it x squared. Now, when I have 2x squared, I distribute that exponent over the multiplication. So I have 2 squared times x squared. which means ultimately I have 4x squared minus x squared. And this number 3 pops out. So if your altitude squared is equal to 3x squared, I square root both of them to get altitude. So I have square root of 3x squared. The multiplication of the 3 and the x squared are allowed to part ways because we can distribute roots and exponents over multiplication. And this interesting little number, root 3, pops out. So if you claim the side across from 30 to be x, then the side across from 60 is x times the square root of 3. And the hypotenuse is 2x. So let's go back up to the top and fill that in. This is 2x, and this is x times the square root of 3. Now, for some of you, some of you maybe already finished solving the problems that I have on the classwork. Am I right on that? Did some of you already finish the classwork? Some of you have already gone through and solved it. Yeah. So for some of you, you're ready to go. You've got it. But I know that always a good portion of the class struggles a bit in what to do when you're finding the missing sides. So here's what I recommend. If you need help, what you can do is figure out which of the sides is known to you, and then let that side equal. If it's a leg on a 45, 45, 90, let the number that leg is equal x. If you know the hypotenuse, write that hypotenuse number equals x root 2. If you're on a 30, 60, 90, and you have the length of the side across 60, take that number that is across from 60 degrees and write equals x times the square root of 3. And then you can isolate x and find the other sides that way. So again, I found that for some people, this helps them a lot. So let's look at the first example. So the hypotenuse on a 45, 45, 90 is x times the square root of 2, where the legs are x. So you can say the length 14 is equal to x times the square root of 2. Then when you solve for x, you are dividing by root 2. And a lot of times these are simplified so that you don't have roots in the denominator. And one of the reasons is sometimes it really does come out nicer, but sometimes it comes out worse. Know that the answers are going to be written in a simplified root form where you don't have a square root in the denominator. A lot of math teachers are not happy about that being a rule, that you have to rationalize the denominator. It's really unnecessary. But you need to also know that when you read answers to these problems, anywhere you go, they're going to be written in a certain format. And you need to know how to get into that format. So I'm going to take 14 divided by root 2. And the root that is in the denominator, if I multiply top and bottom by that root, so times root 2 times root 2, that will allow me to eliminate having a root in the denominator. Sometimes it comes out looking better than it went in. Sometimes it looks worse. So 14 root 2, and then in the denominator, root 2 times root 2 is what?
Yes.
Okay, 2. Then you can simplify this fraction because you have 14 being multiplied and 2 being divided. So 14 divided by 2 gives you 7, and then you still have times the root 2. So it actually did end up looking better in the end. But now you have that these sides are 7 root 2.
Is there a way that we can simplify it further?
No. No. 2 is a number that cannot be taken out of the square root. The only way you can write it differently is as a decimal number. Otherwise, that's as simple as you're going to write it if you stay in square root form. Okay, and then I've got one more example for you. And I felt like I didn't need to do too many examples because you've done this before. So what I do is first look for the 30-degree angle. The side opposite that 30-degree angle is the x. The hypotenuse, which is opposite the 90-degree angle, is always double that side that's across from 30. And if you want, you can almost imagine an equilateral triangle, and that helps you to visually see that that makes sense, that the hypotenuse is going to be double this length. And then the side across from 60 is x times the square root of 3. So if you do this, then you can look at the side that is length 12, and you can write an equation: 12 equals x times the square root of 3. Then divide by root 3. What? Oh, yeah. Yeah, Google Meet now has backgrounds, but they aren't as good as other backgrounds. Anyway, know that the answer is going to be written so that you don't have a square root in the bottom. So take the number, multiply the numerator and the denominator by whatever the square root is in the denominator. And then check to see if you can simplify. 12 divided by 3 is going to give us 4. And then 4 root 3 is the simplest way that it's going to be written. So that's what x is equal to. That means when I come over here to the side I have labeled x, all I need to do is say that's 4 root 3. Done. Come over here to the side that is 2 times x, and when I multiply 2 times 4 times root 3, I can multiply together the things outside the root, but I cannot bring them together with the 3 that's under the root. So I end up with 8 root 3 for the length of this side. And now I want you to know that if you can do this quickly without showing any work, I am fine with that. If you need to go through these steps to get it right, go through these steps to get it right. And know that this, while you're having your break, you're going to make sure that you get set really well in your head, not only SOH-CAH TOA, but the 3 that we're going to learn tomorrow. They are very, very, very important. Okay, then also with having a break coming up, did I write down? No, I haven't written that down yet. I'm not going to quiz you this week. I'm going to quiz you when we get back after the break. And it's because if I were to quiz you, it would be Friday, and a Friday fourth period right before you go on your fall break. It doesn't go well for people. I learned my lesson the hard way. Anyway, I'm going to stop